Hi, this is lesson 2.5 in geometry, and we are going to actually be talking about using algebraic properties when we're forming logical arguments. And so first, let's go over the algebraic properties of equality. So when you think of an equality, I want you to think about like a balance scale where you have like a certain number of blocks on one side and a certain number on the other so that the scale balances. So if we have a, b, and c that are real numbers, the addition property says that if a is equal to b, then a plus c is equal to b plus c. Now, in other words, if you have a perfectly balanced scale, if you add some blocks to one side, it'll still be balanced if you also add the same amount to the other side. Okay, and so to shorten that when we're doing problems, we're just going to write the addition property of equality. So we'll write a plus sign with parentheses and then an equal sign. The next one is the subtraction property of equality, which says if a is equal to b, then a minus c equals b minus c. So if we have a balanced scale, a on one side, b on the other, and is equals, if we subtract a certain amount from one side, we also have to subtract a certain amount from the other side to keep it balanced. And so we will call that the subtraction property of equality. The next one is the multiplication property. It says if A is equal to B, then AC equals BC. So if you multiply the number of blocks on one side by 5, then you'd have to multiply the number of blocks on the other side by 5 to keep it balanced. And we'll just write multiplication property of equality because sometimes the x gets confusing. All right, so next, division property. If a is equal to b and c is not equal to 0, then a divided by c is equal to b divided by c. So if we divide the number of blocks by something by like 2 by half, if we divide the number of blocks in half on one side, we have to also divide the number of blocks on by half on the other. Sorry, I'm having trouble getting that out. And we'll call that the division property of equality. Okay, so what you do to one side of an equality, you have to do to the other. The next property is the substitution property. If a equals b, let me erase this. If a equals b, then a can be substituted for b in any equation or expression. Substitution property. If something is equal to something else, then you can substitute the first amount in for the second. All right, the next one is called the reflexive property of equality, which says A is equal to A. The way that I remember that is the word reflexive. Okay, I think about when I look in the mirror, what do I see? Well, I see myself. I see my reflection. So when A looks in the mirror, it sees A. So it's seeing its reflection, but of course, the word we use for math is called the reflexive property. So that's just my little way of remembering that word. The next is the symmetric property of equality. So if A equals B, then B equals A. So it's equal either way you write it. The next one is called the transitive property. It says if A is equal to B and B is equal to C, then A and C are equal. So if 0.5 equals 1/2 and 1/2 is equal to 5/10, then you could say 0.5 is the same as 5/10, which is true. And then the distributive property, if A times the quantity B plus C is equal to A times B plus A times C. That's the distributive property. All right, so some examples. The reflexive property of angle measure, if we're using that, the measure of angle B would equal what? Well, remember when you look in the mirror, you see your reflection, so reflexive property, it equals itself. Transitive property, so if CD equals GH, okay, transitive, and GH equals something else, RS, then what do we know? Well, then we know that the first, this is kind of like the domino one, then CD is equal to RS. The first is equal to the third. That's a transitive property. Symmetric property of equality. So if BC equals RL, well, symmetric means you can just turn them around. Then RL equals BC. Okay, so let's talk about how we're going to use these algebraic properties in logical arguments. We're going to solve this equation for x, but we're going to justify each step using one of the properties. So first of all, you'll notice that the statement is the problem that we were given. So the reason that we write for the first statement is that that was given to us. Now, if you were solving this, there are different ways you could go about it. So you could write your steps in a little bit of a different order, but I would probably get the letters on the left. So I would add 3x to both sides. And what that would give me, and I write this for step 2, is 5x plus 5 is equal to 20. So the result of what I just did would give me 5x plus 5 equals 20. So the reason that I can do that is I added something to both sides. The name of that is the addition property of equality. Okay, the next thing I want to do is isolate the variable term, which means I subtract 5 from both sides. So that would give me 5x equals 15. What did I do? I subtracted from both sides. So that's the subtraction property of equality. All right, now if I'm trying to solve for x, I would divide both sides by 5. So x equals 3. And why was I able to do that? Because of the division property of equality. As long as you do the same to both sides. Okay, we're good. And we solve for x, so we actually don't need another step right there. All right, let's do another one. So first of all, we're going to write the statement that they give us. And that is given. That's going to typically be your first step in every proof, given. So next, if I was going to solve for x, I would distribute -4 times each term in the parentheses. And so that is the distributive property. Okay, and then I would add 8 to both sides. So I'd have a -44x equals 88. And so I added to both sides. That's the addition property of equality. And then lastly, I would divide both sides by -44. Okay, and you always write what you end up with. So you'd end up with x equals a -2. And what did we do? We divided. So that's the division property of equality. So we just justified each step in how we solve that equation for x. All right, and there are just a couple here for you to practice. I'll just do one of these. The first one is given. Okay, the next one. Now, this time we're not solving it ourselves, so we have to try to think about how did they do it? What step did they take? Sometimes when I do this, I look and I say, okay, look at what's different here. These are both a -12. The 8 gets carried down, but what changed? Oh, they subtracted 7x on both sides. So that is the subtraction property of equality. And then looking to see what they did to go from the second step to the third. Well, that's the same. Let's see. What's different here? Oh, they added 12 to both sides. So that's the addition property of equality. And then to go from here to here, the x stays there, but they divided both sides. So that's the division property of equality. Okay, and in this next one, I'll just write the first one is given. The next one, they distributed, so that's the distributive property. And then the 5 stayed the same, the 13 stayed the same. They subtracted the 4 from each side, the 4x, so that's subtraction property. And then they added 5 to both sides, that's the addition property. All right, so let's look at one of these where we're combining some geometry with algebra. It says, what is the value of x? Let's justify each step. So when we look at that, what do we notice about those angles? Well, they're supplementary. How do you know that they are supplementary angles? Well, that's because angles that form a linear pair are supplementary. So then if they're supplementary, what do you know about them? Well, if they're supplementary, if you add the two angles, the measure of angle AOM and the measure of angle MOC, if you add, they add up to 180. Well, the reason for that is because the definition of supplementary, oops, I'm trying to get a pen here. The definition of supplementary is they add up to 180. So now, this is interesting. So if we look at how they went from step 2 to step 3, what changed? Well, instead of the measure of angle AOM, so this is angle AOM here. Let me move that over. Measure angle AOM. Let me write this down. And what does that equal? Oh, it equals 2x plus 30. The measure of angle MOC, that's this one, that equals x. So what they did is they substituted in what each was equal to. So the third step there is substitution. Now, the next step we need to talk about that because the book does it differently than what I do. If you look, what did they do here? They added 3x, but here's what you have to understand. They did not add something to both sides. They combined like terms here. 2x plus 1x equals 3x. And so they're just simplifying in that step. So your book is going to call that distributive. We're not going to call that that. We're going to call that simplify. So whenever you combine like terms, call it simplify. In the next step, they subtracted 30 from each side to get 3x plus 150. And in the last step, they divided each side by 3. All right, let's do another type of problem that combines geometry and our algebraic, using algebraic properties. So it says write a two-column proof. We are given that the measure of angle 1 equals the measure of angle 3. So the measure of angle 1 that's marked here is the same as the measure of angle 3. Okay, so that is given. What we want to prove is that the measure of angle AEC, so let's look at that, angle AEC. Okay, so that would be 1 and 2 together. Okay, that forms angle AEC. That is equal to the measure of angle DEB. So from DE to B. Okay, DEB is 2 and 3 together. And we have to prove that. Now, when you do problems like this, what you want to prove is always the last step. Okay, your givens are typically your first step. What you want to prove is your last step. So, and then you want to try to understand it. Well, let's see. If 1 and 3 are the same, okay, that's given. Now we're trying to show that this big red angle is the same as the big blue angle. Well, we know that the 1 and the 3 parts are the same. Well, they both have angle 2 added onto them. Okay, so we're adding an equal amount onto two things that are already equal. So we're going to first state that angle 2, which is what we're adding onto both parts, is equal to angle 2. So that is the reflexive property. So now we're going to go back to this. We know that the measure of angle 1 is equal to the measure of angle 3. That was given to us. So remember that you can add something to both sides as long as it's an equal amount. And that's what we did. We added measure of angle 2 to measure angle 1. We added measure of angle 2 to measure of angle 3. So in that next step, we just added. So that's the addition. Oh, let me go back and change that. The addition property of equality. So now we're going to look at measure angle 1 plus measure angle 2. Well, that equals measure angle AEC. That equals the red angle. Remember in the first chapter we talked about how the two smaller angles, if you add them together, they equal the whole angle. So that is the addition, the angle addition postulate. Okay. And then you can also, we want to be talking about angle DEB, which is the blue one. Well, what's that made up of? Angle 2 plus angle 3, the measure of angle 2 plus the measure of angle 3. So again, that's the angle addition postulate. Forgot my E there. Now, let's look at this. This is interesting. Here, the measure of angle 1 plus the measure of angle 2 equals the measure of angle AEC. Well, right here it says measure angle 1 plus measure angle 2. So here's what we do. We can substitute, because the measure of angle AEC is equal to angle 1 and angle 2. Well, you can, instead of writing that, you can substitute in the measure of angle AEC, which is what they did right here. And over here, the measure of angle 3 plus the measure of angle 2, what does that equal? It equals this, the measure of angle DEB. So instead of writing this side, you can substitute in the measure of angle DEB. So in the last step, we used substitution. So now we just step by step showed why this is true. Okay, so the measure of angle 1 was equal to the measure of angle 3. We added angle 2 to both angle 1 and angle 3. And that gave us the two larger angles then. All right, let's do that one more time. So first, we write our given. Segment AB is congruent to segment CD. That is given. Okay, and what that means is if they're congruent, what does it mean? It means that their lengths are equal. That is the definition of congruent segments. Okay, so AB, that length, is equal to CD. Let's look now, where are we trying to go with this? We are trying to prove that the length of AC is this one, is equal to the length of BD, which is this one. So AC, notice, would be AB plus BC. That would be AC. That's AB plus BC. I'm going to write that that is AC. BD would be BC plus CD. All right, so notice there, we know that AB and CD are equal. What did we do to both of them? We added a BC on. So let's make the statement that we're going to add BC onto both sides. But before we do that, we always want in geometry, we want to say that the length of BC equals the length of BC because we do want to show that we're adding an equal amount onto both sides. And that is the reflexive property. And now we're going to add BC to the AB and add BC to CD. So we're going to add AB and CD are equal. Okay, and now we're going to add an equal amount onto both sides. And we can do that because of the addition property of equality. Now, what do you know about AB plus BC? What does it equal? Well, it equals AC. So we'll make that statement. And what do we know about CD plus BC, or BC plus CD? That equals BD. That is that the two smaller parts add up to the whole. That is the segment addition postulate. And so instead of writing AB plus BC, I'm going to put in what it's equal to. It's equal to AC. And instead of writing CD plus BC, what is that equal to? It's equal to BD. So I substituted in there equal amounts. All right, but we have to prove that they are congruent. Well, we know by definition of congruent that if they are equal, two segments are equal in length, they are congruent. So then we can just go one more step and say that segment AC is congruent to segment BD. And the reason we were able to go from step 6 to step 7 is the definition of congruent segments. All right, that's what we have for this lesson now. So go ahead and do your practice problems and let me know if you have questions. Thank you.